In this problem, we're asked to find the volume of the solid generated by revolving the region bounded by the parabola y equals x squared and the line y equals 1, first around the line y equals 1, then the line y equals 2, and finally the horizontal line at y equals minus 1. So 3 different axes of revolution, 3 different solids. Let's get started finding these 3 volumes. First, let's start by sketching the region so we understand what will be revolving. So we're taking the parabola y equals x squared, just the standard quadratic function, and the line y equals 1. So there's the region we're going to be revolving. In part A, we're revolving around the line y equals 1, right here. So we take that parabolic region, we spin it around that line, and we get a solid that would kind of look like a parabolic football. So not really a football, but kind of that general egg shape. And there's no hole. It's a complete solid, so we'll be using the disk method here. So I'll have pi times some radius squared, and because I'm revolving around a horizontal axis, we'll be integrating with respect to x. Well, my region starts at minus 1 and ends at positive 1. So there are my bounds. And now we just need to find a radius function. Well, I'm revolving around that axis, and that's a radius. And so I see 1 minus that function value. So there's my radius function. R of x is 1 minus x squared. That's what's going to go in here. So if we expand this binomial expression, we'll be able to integrate fairly easily. Go on, factor that pi outside. 1 minus 2x squared plus an x to the 4th. All right, let's find an antiderivative, and we will have found our volume. All right, and then we just need to plug in a 1 and a minus 1, and I'll get 1 minus 2/3 plus 1/5, which, when we do our arithmetic, we will find that's 8/15. And we plug in a minus 1, well, I'm going to get the same things with the opposite sign, so it'd be a minus 8/15. So I really just have 8/15 plus 8/15. And that volume, 16 pi over 15. And now, having seen this, I realize, or remember, I also could have just found half the volume, integrate from 0 to 1, and then double it. That would have just given me a 2 pi times 8/15. So either way would work, but we have found the volume requested in part A. In part B, we're asked to revolve the region around the line y equals 2. And now I see the big difference. When I take this region and revolve it around that higher line, now there's going to be a hole in my solid. It'll look like a parabolic region that's had a hole drilled through it. So instead of thinking about the disk method, I'll be using the washer method. So this time, still integrating from minus 1 to 1, but I'll have pi times a big radius squared minus a little radius squared. When looking at our diagram, my big radius goes from this line to the parabola, and the little radius goes from the axis of revolution to the line y equals 1. And so let's see, that would be 2 minus x squared. And then that distance is just 1 unit. There's literally one unit between the lines at y equals 2 and y equal 1. And of course, 2 minus 1, 1. So any number of different ways of thinking about that. All right, I'm ready to evaluate this definite integral to find my volume. All right, so I need to expand this. So I have 4 minus 4x squared plus x to the fourth minus 1, which I'm just going to go in and combine up here and make that a 3. So I'm ready to find an antiderivative and evaluate. I apologize for the interesting formatting here on the board, but I think we'll see what happens here at the end. I still have that pi hanging out front, and here's my antiderivative. 3x minus 4/3 x cubed plus 1/5 x to the fifth, evaluated from -1 to 1. Plug in a 1, plug in a -1, do some arithmetic, and we'll find out that this volume is 56 pi over 15. Go on and take a moment to plug in those bounds and make sure that you agree with my arithmetic, but we found our volume here in part B, leaving us just with one part, revolving the region around the line at y equals -1. So again, when I revolve the region this way, I'll get a hole. Now this time the hole has the kind of parabolic shape to it instead of just being a cylinder. But in the same way, I'm going to be looking for a big radius and a small radius. So I'm going to set this integral up here, but probably evaluate it on another board. All right, I need a big radius and a little radius. And this time the big radius, coming from the top of the region going down to this axis of revolution, well, that's 1 unit down and another unit down. There's 2 units between those 2 lines. And again, you could think of a top function minus bottom function, so that would be 1 minus a -1 is 2. And now I need the small radius, which is the distance between the parabola and this green line, this green axis of revolution. Well, you go up to x squared here and go down 1 unit here, so that would be x squared plus 1. Intuitively, and again, a top function minus a bottom function, x squared minus a -1. So there's my definite integral that will find the volume here in part C. Let's see about working it out on the next board. Go on and write that pi out front. All right. Go on and multiply this out. So x to the fourth plus 2x squared plus 1. And I end up with a 4 minus 1 here, a 3 out front, minus x to the fourth, minus 2x squared. Let's find an antiderivative and see what happens next. All right. So now I'm ready to evaluate this. I need to plug in a 1 and get a 3 minus 1/5 minus 2/3. Now I need to plug in a -1, and after I've done all of the arithmetic, get a 64 over 15, or 64 pi 15ths. And again, you should actually check and make sure the arithmetic works out. But there's our volume in part C. So we've officially done all 3 parts of this problem.